All right, welcome everyone. We're going to start our session, Insight into the Utility Network. How many of you, I would assume partners, have actually worked with the utility network through Alpha or now Beta 1? Come on, raise those hands high.
Yeah.
So a fair number. So does that mean everyone else who didn't raise their hand is an anxious user awaiting the next beta release? Yes. Good. So I'll do the plug for Larry Young. He's hiding over in the corner. That beta release. You don't have a slide at the end, do you?
No, we'll make one
schedule?
while you're demoing.
Okay, good. So that where we are on the project, we'll give you that quick heads up. We just, at the end of January, released our first beta. We've been, of course, in alpha many years, had been providing our partners and getting feedback and building more capabilities into the solution. We did the initial beta and we kept it limited, primarily for one reason. And when we say limited, we made it available to our partners who had been in the alpha program and all our distributors, with the caveat that they were more than welcome to work with users, either clients, anyone, but they were responsible to do all the interfacing, support them with all questions and problems, and then feed it back to us. And then from that time, internally, we've done a lot of training, knowledge transfers with our staff, all throughout ESRI, our professional services team, our support teams, our utility teams, to get them up to speed. So when we make the public beta, which will be in April, they then become responsible to support it. So you're going to be able to call support, log incidents, get feedback and support. Because of course, Erik is far too busy to read email, so we can't have everyone email Erik. So Erik Hoel, our lead developer. My name's Tom Brown. We're going to go for the next hour and give you a high-level view of understanding the utility network. We want to try to keep this interactive, take questions along the way. Of course, I'll give you an idea. The knowledge transfer that we did for our team took 4 days, right? So we're going to give you a high level in an hour. So of course we want questions. So we'll take a few throughout. Erik's going to do slides, not too many as usual, and then I'll do a demo here and there to try to nail down the concept. So over to Erik.
Okay, and all questions must be asked in a form where they can be responded to with a yes or no. Maybe. Okay, let's see here. So what is the utility network? It's basically a new framework that's intended to support all of our utility and telco solutions, our users, and all the business partners that circle around here. You do the Wayback Machine. Remember when ArcGIS 8.0 was released? That was very much focused on the utility domain. We came out with the geometric network. We came out with version management. We were really going after the utility domain very hard back in 2000. Now we were chartered by Sud Menon, our director, and our former director, Scott Morehouse, the guy with the big beard, to come out with some new disruptive technology that could take us into the next 15 years. Carry you, because the old one's 15 years old. Now it's time for a new one that'll last for another 15 years or so. So what is it? It's basically allowing you to edit, analyze very complex networks, much more complex than before, using the entire ESRI platform. By this thing is based upon Portal. Things will be sitting in Portal. We'll talk about that later. You'll use it through the Pro Desktop, talking to Portal. You can use it through mobile devices, talking to Portal, or in a standalone environment. And also you can use web apps to talk to Portal in order to do your analytic operations, your editing, and everything else that you would expect with the utility network. Okay, you also have the ability to do syncing from Portal, of course, to mobile apps. One of the key things that we've seen as your domain, these utility domains have gotten much more complex. Look at electricity with distributed power generation, with electric cars, with smart metering, with more and more SCADA. The requirements are changing, and you're required, if you're going to be productive or successful moving forward, be able to have much better high fidelity representations of what your assets really are out there in the field, okay? So that's what we're focusing on. Here's some of the feature functionality really quickly. We'll go through these in more detail. First, cross-platform support. It's all portal-based, services-based. It is a service-based architecture. This is the first new dataset type that ESRI development has come out with that is truly services-based and only services-based. You will not be using client-server to connect to your enterprise databases. You will be connecting to services from your client applications. It has an updated model that contains things such as, we'll go through these, all different types of associations for specifying connectivity, containment, or structural attachments. You can support terminals on devices. Think about like a transformer that has multiple terminals on it. There's a very powerful and expanded tracing framework that you'll be able to configure and do some really remarkable things with. Built-in support for network diagrams. Network diagrams is our new vernacular for schematics. It's built in. You don't have to buy anything else. It's just part of the utility network, the ability to create schematic diagrams. Big validation framework to allow you to QA/QC your data. Basic source management, by that, maintaining your circuits or your feeders or your pressure zones or your isolation zones. Also export capabilities. It has an updated transaction model. We've gone and reworked versioning. There's a new versioning implementation that's based upon the change tracking model. We see it as being much more flexible, much more performant, and far less overhead, and it also brings us into the temporal domain. An attribute rule framework that will be supported across the platform. This includes Portal, Pro, web apps, as well as runtime. And then enhanced editing. We've been working very closely with the Pro editing team to enhance the editing experience. There are new types of layers, composite map, and subtype layers that offer advanced performance optimization capabilities, and then central storage of maps and projects. Now, talking about building a better framework, what we were doing in the past, you can think of it as being this sort of little layer cake diagram here, where on the left you see some of the core stuff, then you have on top of that some partner stuff, and then on top of that some client customizations and whatnot. Now what we're trying to do is actually greatly extend the core platform inside ArcGIS to provide many more things than we've done previously. Also, the solutions team, the maps and apps team will be providing basic data models as well as a large collection of maps and apps that you'll be able to use. Partners will then continue to extend it to provide even better domain data models, more advanced circuit management, editing, productivity type of tools, all kinds of productivity tools that you would expect. And then finally, there's the configuration aspect of the system.
Erik, have you had a breath yet? Breathe.
2.
Any questions up to this point? Some simple questions, thoughts.
It's like Smokey and the Bandit, we have a long way to go and a short time to get there.
Keep going.
Okay, yeah, I'm sorry, I started getting on a roll here. Because I know we all want to see Tom giving these very compelling and insightful demos and stuff that are much better than slides, okay? Even if they do have animations and fancy colors and stuff. Okay. Now, one of the interesting things, think of the utility network as being a container that contains one or more domain networks. It will always contain a structure network, things such as your power poles, your duct banks, your substation, things of that, your structural aspects that are not active parts of your network. And then you can define one or more domain networks. So here, you can see, okay, say we have our water network, gas network, electric, telco. Everyone has a structure network by default, okay? Then, inside each domain, you can have other types of networks being put in place, such as you determine which type. Say you're in electric, and you want to have both transmission network as well as a distribution network inside your electric network. Or in gas, the same can be said. You can have gathering networks, you can have transmission networks, and you can have distribution networks. And if you really want, you can put all your gas networks and all your electric networks in one utility network if you so chose. We're not limiting you to one little domain network and you're going to have to worry about doing cross-domain things. It's all inside the utility network. So here in water, you may have your water distribution network, and then maybe you have your sewer network if you're a water organization. In a gas network, okay, maybe you just have gas distribution and electric. We see transmission, distribution. Telco, maybe there's the fiber network. And another thing that we're concentrating on with our solution team and other experts in the Esri is to figure out how to also be able to support cathodic protection networks inside the water and gas domains where you do have these buried pipe networks. It's very important.
Don't go to that. Don't go to the next slide yet.
Okay.
So one of the very important aspects of our project in this, what we're building as a solution, is that, as we've highlighted here, there's all these domain-specific industry, water, sewer, electric, gas, telco, that are domain-specific models, right? What we will be providing through a mechanism called asset packages is a very simple way to download and create your utility network for your specific domain. These asset packages will lay out the basics, because pretty much the patterns that we've seen across each domain by working with our users and organizations, there's always the same type of attributes, same type of rules that apply within a domain. So the asset packages will allow you to easily create your utility network and have it configured for you so you can be up and running quickly. Of course, then, you can make the changes to your own utility network, add additional attributes, add rules, associations that we'll talk about next. So it's really configurable. But what's important is we give a starting point that's very important. We'll have models that represent for electric, like the North American electric distribution model or transmission, and we'll probably partner with some European distributors or partners to standardize on a European electric model as well. So that's the pattern and the deployment model that we're moving towards as well. That's going to be there when we have the first release.
Yeah, so there will be the base standard models as Tom was describing, but then for your organization, you may want to further tweak it. But the important thing is to have these kind of community accepted base models such that business partners and others, yourself, maybe you write some open source code where you can create tools and little apps and you can share them among yourselves, or you have these common tools that can go everywhere. So that's one of the reasons why it's so important to have these models.
Right, and the models themselves, of course, any user can define their own model. And all of the capabilities are simply created through geoprocessing tools or Python, right? That's the mechanism for your administrator to actually define the model before sharing it and deploying it through your portal for your organization. All right, you want to flip me over to one?
You're on one.
So what I wanted to start with is just a quick example of working in Pro. Again, the project looked at how to build this new solution for 15 years, but first thinking about it from an end user's perspective, right? A map-centric way to how our users will interact with layers, right? Because it's these layers and maps that get shared through the organization that are then your web maps that are consumed, or your maps that are pulled down for your collector and through your runtime applications. So it's the most important way to understand the data itself. But how it's actually persisted in the model is very much different, which an end user doesn't really care about, right? They care about the layers. They care about the attributes and how they do their tracing and analytics. So in this example, here's my typical electric distribution and transmission map for my utility in Southern California. And thankfully, Sempra has shared a subset of their data for us to work with, so I can actually present here. And essentially, I come in, and of course, at a high level, I can see all my various service territories for my organizations. But as I drill in further for electric, a common way to look at the data is via its circuits, right? The circuits that make up essentially a circuit map now. Now, if I was in a pressure network doing gas or water, these lines could represent, of course, my pressure zones. Or I could model these in polygons, and those are more capabilities in the utility network. So essentially what I have is a single substation with 15 different circuits, and that's covering my service territory. So again, as I drill in further a little bit more, now what I'm seeing is a quick representation, again, of all those circuits, but I'm drilling down into more detail. And what's important to me at this scale is that I can see where the switching devices are that separate the circuits. Maybe in my gas pressure map, and I'll show you that later on this morning, it could be a regulator station that separates the pressure zones or the critical valves used for emergency isolation zones. So now, again, as I continue to drill in further, let's center this. What you saw on that previous map were these very fast ways to visualize either the circuits or a way to quickly see all of the features of where they are for my medium voltage lines. But then as I drill in, I'm now going to actually start to see the individual features that make up the overhead lines, the underground lines. As well, you can now start to see how different transformer assemblies or fuse banks appear on the map as assemblies. And then finally, of course, if I really drill down into here, I can just see the individual things where I can start to see street lights, I can start to see the low voltage lines, I can see the line end and poles and so forth. I can get into much better detail. Now, how are we actually doing this? So if we focus on the distribution device feature class or layer, right? We have all these sub-layers present. And those layers, of course, are always the type of assets that I'm working with. Now, Erik alluded to very quickly on that overview slide, talking about new capabilities within Pro and the platform as we continue to roll these out across the platform. The solution is not a desktop-centric application, which we built at 8.0, right? At 8.0, with the introduction of ArcMap, it was all about deploying client-server capabilities within your organization, right? Well, today, that doesn't meet the requirements. It has to be a very large platform solution that can push out to my mobile workforce, my staff who's coming in through web clients and so forth, or very dedicated specific applications you could build via runtime. So, again, to enhance these capabilities, we're introducing a new type of layer in the platform, essentially called a subtype layer. So also, many of the things that we're building are not just for the utility network. It benefits the entire ESRI platform. It's typically the utility industry with their complex business requirements and maps that help push the ESRI platform with new capabilities that all our domains benefit. And this new subtype layer is one such example. So what I have in the map is essentially this subtype layer called distribution device. Every sublayer in that grouping, I'm not going to read them all out to you, but almost 20 of those are essentially subtypes. Each one of those is still a layer in my map, right? And I could do this today with ArcMap or Pro. There's nothing special here using a group layer. But what the difference is with ArcMap or a group layer, each of those layers is a request to the data source, right? Because we want to render it, we have to go do the spatial query, we got to bring back the data. So you can imagine right there's 20 round trips to our data source. Either it be the feature service or map service, it's that round trip of pulling back data. What the intelligence of the subtype layer provides us, it's one trip to the data source. So now our layer is smart to say, I know which of those sublayers is enabled. Of course, I know the extent of the map or the request. Now I can go to the data source once, bring back all the features that meet the criteria of the layers which are enabled, and then render it. What does that mean? Performance, right? We have to, in such a system that is going across the web, we have to be as performant as possible, as few number of requests necessary back to that data source to retrieve the data. And of course, in more advanced caching capabilities on the client side that we're also building. So that's one example. So essentially all of these are subtype layers. And each one, if I were to look at my, let's go down to distribution lines, right? I've got bus bars, I've got overhead, I've got underground, low voltage, medium voltage. Those are all specific subtype layers. Now, another thing we have are the properties of the utility network. So if I just have my, let me show you, sorry. If I show you my utility network layer, it has 3 sublayers. It tells me my dirty areas where edits take place, and it tells me where errors exist based on the rules when we update the topology. But I can open up the properties of my utility network. Now I can start to understand how it's been configured. What are its capabilities? And as Erik highlighted, we have things such as the structure network. Every utility network will have a structure network. And if I go in here and look, I essentially have 3 specific classes that manage my structures: junctions, lines, and boundaries. And if I were to look at my structure junctions, I can start to see the specific asset groups that are used to represent these things, like a guy wire, a handhold box, or a junction box. We have manholes, we have pads where transformers are mounted, pedestals, platforms, poles, substations, right? All of these asset groups are essentially what we had previously as feature classes. So the utility network model, to achieve this performance, this throughput that we need, is essentially consolidating these models into very few number of classes and leveraging subtypes. That's why we introduce new subtype layers. In addition, we can define at the subtypes these behaviors of these things. So a cabinet, right? A cabinet is something that contains devices within it, right? You see them out in the field, a fuse cabinet. Well, it's a container, right? And I can define the behavior. Or I could have a pad, which is a structure in which things are mounted to, or a pole. Devices are attached to poles. These are type associations Erik will go into next. And that type of modeling now is at the subtype, asset type level. So very detailed capabilities now to define how we represent things in the real world and the rules that we associate with the individual items. So in my, I said I was also a distribution, right? I have an electric distribution network. And again, you can see I only have 4 classes to model my entire distribution: junctions, devices, assemblies. Assemblies are containers that have multiple units or devices within there, like a transformer bank. The assembly is the bank, or a fuse bank. There's multiple individual fuses. And then finally, I have, of course, all my rules. I can define rules being junction, how connectivity can exist between devices or junctions. I've got junction edge that defines how the edge may connect to a specific junction at the asset group, asset type level. So very fine level of detailing. And that becomes very important because we know the GIS is the backbone that's feeding many of these external systems, either for modeling or for outage systems, design packages, and so forth. And then Erik will start to show you some example of terminal configurations. In my example, my circuit breaker has multiple terminals, transformers. We also have what are named categories for the purpose of a way to tag a collection of asset groups to describe them in further detail to be used during tracing. And I'll show you that example later. Now, the final thing I wanted to quickly show you, if I zoom out a little, is I mentioned that cabinet example as containment. And I'm going to just mouse around here for example. So here is the actual substation in the data. So on my map, I've got some features, these red and blue lines, which are essentially the ducts, the linear containment of the underground circuits, the electric wires. In green is my actual polygon representing the substation. And that boundary is a container for all the devices in the substation. So one of the things that we've added is this quick ability to turn on and off what is contained, or essentially linear containment, or contained in an assembly. And what this is doing is visiting each layer and turning that on and off. Now you can actually see all the objects that were in these linear containers, so you can see how busy the map is, right? That's the benefit of some of this containment. We can start to hide these individual units. And I actually have a complex substation down here. If we zoom in, that is the actual substation in downtown San Diego of all the bus bar, transformers, all the things that you find in a substation. So again, it's this way to model data for the performance of visualization techniques and how we move data between the source and to the client. Because the majority of the time, I don't need to see the content of a fuse bank. I may know where the fuse bank is, or the pad-mounted transformer, or my regulator station for pressure networks. But I know it's there, and until the engineer really needs to go there and turn on the content is when I need to actually see it. So that was a lot. I'm going to hand it back to Erik.
Yeah, what was interesting about that? There were many things in there. Some takeaways. When Sud Menon and Scott Morehouse spun up this project, they told us performance is key. That is the single most important thing that we're trying to address in this domain. And as such, this is part of the reason why we went to this interesting model where we had a very small number of feature classes. Yet we started introducing new concepts. Not only do we have subtypes, or what we relabeled as asset groups, but we also have the asset types that allow us to do further specification of the rules and whatnot. But the key thing is being able to present the end user with their 75 different layers or 100 different layers that they expect, but behind the scenes there's just a small collection of feature classes. Also, for all those properties and everything that Tom was displaying, that stuff is all very configurable, okay? It's not a fixed model or anything. You can do whatever you want to with these things. So I'm going to see if I can get my slideshow working again. This is horrible. Oh, it works again. I had to make the slide that says when all this stuff's coming out, and you know, you go into one of these black holes where you can never get your projector working again. Well, okay, good. Now, let's talk a little bit about connectivity associations. Inside the utility network, much like the geometric network, you can establish connectivity, essentially implicit connectivity, based upon XYZ coincidence, provided that you also have the appropriate connectivity rule set up, saying that this particular thing can be permissibly connected to this other thing. That's one thing that's very important in this whole system. It's very rule-based, where if you try to attach, say, a lateral to a main substation transformer, if there's not a rule there, the system will not allow it, okay? We really try to prevent the creation of bad data, both through the interactive editing experience as well as through the APIs and SDKs and everything else. So, the interesting thing here is not only can you have connectivity established between things that have X, Y, Z, yes, Z, the utility network is always Z enabled. Okay, you saw that a little in the plenary, I think. Sud was up there and he showed some kind of cool thing where you could see some power poles and devices, and it was very 3D. By default, this thing is 3D enabled. You can also use connectivity associations to specify that things that are not XYZ coincidence can still be connected together, okay? That's very nice if you like to have, say, your transformers offset from your main lines, or, you know, inside a substation you want to just play around and make things all cartographically nice, but you don't want to have to draw all the various different lines and whatnot to connect everything together. Let's see, what else? Connectivity associations can be defined between either 2-point features or between the end of a linear feature and a terminal on a point feature, if the point feature does support terminals, okay? And the connectivity rules that are established limit what can be connected. If you try to connect things that are not permissible or it's indeterminate, maybe there are too many options, during the build or the validating of the network topology, when we maintain the network index, our network topology, behind the scenes, we will flag errors, we'll report errors, and allow you to identify them and then go correct the problems in your data. Containment associations. Tom talked about this when he was talking about the substation inside San Diego, the Old Town substation. You can have things such as trenches. Trenches contain lines. You can have duct banks that contain ducts that can contain lines. You can also have things such as a substation. A substation can contain bus bars and transformers and all the rest. Or a water pump station can contain pumps and motors and check valves and who knows what not goes into one of those. Now, only structures and assemblies can be containers. Devices can be containers, cannot be containers. They can only be content, okay? Structures and assemblies themselves can also be content inside a containment association. And containment is supported on point, line, and polygon features. Polygon features being the substation boundary that Tom showed. Okay, so for a point, that could just, maybe you choose to have your pump station just represented as a point rather than a polygon. It's your choice. For linear things, this would be like a trench or a duct bank or something underneath the ground. Structural attachment, these things are a little bit like containment, but, well, it's sort of more intended to model things above ground. Here in the US, we have a lot of power poles, okay? And people would like to be able to say, you know, either a telco or a electric company would be able to specify what devices are structurally attached to a power pole or a tower or whatever may be the case. So you can essentially specify devices or assemblies are structurally attached to something else, okay? Now, what's interesting is that doesn't mean that when you're doing a trace through the network and you're just following, you know, the electrical connectivity, that all of a sudden the power pole is returned as a result because there is this structural attachment association. No, that's not the case because there's not a connectivity association, not a connectivity relationship. But these things are important for reporting purposes. We got this interesting requirement early in the process when we were talking to people where, say in an electric network, users would like to be able to make a report that says where are all the power poles that represent this circuit or this subnetwork, okay? Or what are all the power poles on this feeder? And this allows you to very rapidly answer those questions just through a simple network traversal operation.
Maybe I can demo that later.
That'd be sweet. Okay, terminals. These are kind of interesting. Terminals are used to represent a connection point on a device. So for example, here's a single phase transformer that you find all over the US. And it has a high side terminal, maybe two high side terminals, it depends. And then it can have low side terminals as well, okay, when it's stepping down the voltage through this little transformer. Now, we decided we needed terminals in order to support the more realistic modeling of some of these complex devices inside your models. Not all devices have to have terminals. It's up to you. You get to specify which devices need to have this kind of a capability. It's very important when you're doing some types of sophisticated analyses, as well as doing data extraction. Now, there are certain rules that we have down below. Terminals, you don't need them on all devices, only certain devices that you determine. However, if a device serves as a subnetwork controller, Tom will talk a little bit more about that later, such as a source or a sink in your network. Say, like in a water distribution network, maybe a pump would serve as the source. Or in a sewer network, the sewage plant serves as a sink. Or an electric, I'm not an engineer, I'm a computer science guy. This is just like, an electric network, maybe a circuit breaker serves as a source inside a subnetwork or a circuit or a feed or whatever you call it. Those are sources and sinks. Sources and sinks are required to support terminals. Sometimes you have devices that want to have high and low sides explicitly represented for analytical purposes, such as transformers. Maybe you have devices whose traversal is asymmetric, such as a check valve in a water network where the flow can only be from one side to the other. Well, you need to be able to represent what's the high side, what's the low side, so the analytic operations do not push the water back through the wrong direction in a check valve, or a network protector if you have a mesh topology in your electric network. And also if you have devices that require node valences higher than 2. You can see certain types of transformers where they have dual low side windings that need to be explicitly modeled, where maybe one set's a 240 volt thing that's going to your lighting systems, and 400 volts to your regular houses that you're feeding. That's sort of in the European model. So those are reasons why you would want to use terminals. Let's show some cheesy PowerPoint animations. My PowerPoint demo, okay? Let's talk about a bypass switch. A bypass switch is used to isolate an electric device that's connected to a line so it can be serviced. In this example, a voltage regulator. The voltage regulator is on the bottom. The bypass switch is a set of 3 coordinated switches that all work together logically. So the red things are the switches. Okay, so you can see there are 2 disconnect blades going vertically and 1 bypass blade, and then the voltage regulator at the bottom. So if the power is flowing from left to right, because the bypass blade is open and the disconnect blades are slow, the power will go through the voltage regulator. However, watch this cool demo. You can switch it. Wow, that's crazy. Where you can close the bypass blade and you can open up the 2 disconnect blades that will then allow you to safely service the voltage regulator without it being energized. Okay? You can remove it, you can service it, you can do whatever you want. Some people say, I don't believe that thing exists. Well, here's a picture of one. Okay? Yeah, we tried to confirm it. We thought people were just teasing us, but yeah, they're real things. Now here's how we model it internally if you look below. This is sort of inside the network topology, inside our network index. You see 4 terminals labeled terminal A, B, C, and D. The 4 terminals, there are 6 edges forming a complete graph within this device that has 4 terminals. If you have 4 terminals, we always form a complete graph based upon the number of terminals inside this device. Now, on the bottom, you see a voltage regulator, and here on the voltage regulator, I guess I chose to represent it as a 2-terminal device. It could have just been 1. It didn't need to be 2. But let's show, in the first case, in normal operation, edges 2 and edges 5 are enabled. Edges 1, 3, 4, and 6 are disabled. That means a network traversal, your trace operation, will go from terminal A through edge 2 to terminal C and then hit the voltage regulator, then go back up to terminal D, edge 5, terminal B, and on outward. Okay?
Erik, let me jump in to make sure our audience is aware. That bypass switch with terminals is a single point in your GIS. It's a single device, right? That's been configured with valid configurations that defines its current state, what Erik was showing before. So showing you that top example is how it exists on top of the pole in the real world, right? It's causing the flow to go to the voltage regulator. But it's a single point feature in your GIS, and that's what's important.
Yeah, that's a very good point, Tom. End users don't need to be burdened with all this complexity. Okay, it's just a point feature that has terminals that has certain configurations that are permissible. So they don't need to worry moving forward about having 3 switches that all have to be switched at the right times. They don't have to worry about the internal topology. This is all hidden from the end user. So then, during the bypass, in the bypass mode, only edge 1 is enabled. Essentially, this system, you can configure this terminal configuration where it has a normal state and a bypass state. And those shows the 2 edge configurations that are enabled under each circumstance. Okay?
So every presentation, we have to let Erik get really geeky in the computer science, or he refuses to present.
What was geeky, Tom? Okay, let's talk about another crazy one. This one's actually very cool. We're in the water domain, and we have a dual flow 4-port diverter valve. I thought these were only like on my swimming pool or something like that. Anyway, what we're trying to model is a diverter valve where water can flow between ports A and B or C and D. Now, if you watch the animation very closely, my demo, you can twist it and divert it so it's now B to C and A to D. You see? That's pretty crazy. These things are real, believe it or not. Okay, so how do we model these? These are things in water networks. We've been told they're real.
And again, the valve is a single point in your GIS with these defined configurations.
Okay, so this is a 4-terminal device. So again, you can see below we have sort of the logical network, or the network, the internal network index representation, where there are 4 terminals labeled A, B, C, D, and there are 6 edges. It's a complete graph, edges 1, 2, 3, 4, 5, 6, okay? Now, when you create this terminal configuration, you will then say, what are the valid paths? You have one type of valid path where it's AB and CD, and so you would say edge 1 is enabled and edge 6 is enabled. Or, in the converse, where it's AD and BC, you'd say edge 3 is enabled, edge 5 is enabled, okay?
And to tell you how that happens from the user's perspective to make that change is simply, we provide a tool, it's a single attribute on that point feature. So when you choose the configuration you want, right, that is stored on that feature. So when you update the topology, that internal graph Erik just showed you then is updated to reflect the state of that device and its terminals. Right? So that's what Erik is saying. An end user would never know. The end user just knows the state that the device is in and what they would change in the GIS, one attribute change.
Right, very good point. Yeah, so users don't have to be encumbered by all this computer science stuff. It's just, they just know valid configurations and they do it through the domains and then, you know, the typical editing experience. Okay, let's finally conclude the slides at this stage with subnetwork management. What are subnetworks? We consider subnetworks, it's a very abstract term to represent connected subportions of your overall network, okay? In the electric domain, subnetworks are oftentimes called feeders or circuits. In the water domain or in the gas domain, you may have subnetworks corresponding to an instance of an isolation zone or an instance of a pressure zone, okay? This is what we mean by subnetworks, okay? It's a logically connected group of assets that all kind of function together inside your organization. Now, subnetworks are used to drive analytic operations. They're very important, apparently, when people like to do labeling, annotation, map making. In this example here, here's Tom's San Diego data set, and each of those colors, we took each one of the subnetworks, each one of these essentially circuits or feeders, and we colored them differently. People like to see that, apparently. It could be, the same thing could be done with pressure zones, or perhaps isolation zones.
How about I show them?
Yeah, let me finish the slide.
Let's move on to a demo. Clock's a ticking.
Okay, assigning units of work, telling people to go trim tree, blah, 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 blah. Okay.
One.
Done.
Move one. All right, we've shown enough of the electric, right? The last map I showed you coming in from a scale where I had the complete circuit map, right? That was nice. Now let's move to the pressure world. Here we're going to work with a gas distribution domain network. So in my gas distribution, I essentially want to model 3 different what we call tiers and their subnetworks. My first tier is called the system network, right? They want to be able to understand for a given system all the pipes and regulators that have connected flow based on what valves and regulators are all open. And all the features that make up that area. So this is actual data from a user in a part of Wisconsin.
We have 18 minutes left.
This might take all of it. So here we can quickly see the entire system. And for this gas distribution company, they manage 20 different systems across the Midwest, right? So the system is the area that connects off of the transmission lines, you know, the big pipes that go across the country, apparently. And it's tied in from multiple sections, right? Anytime they can close down, you know, it isolates and so forth. So there is your entire system of all the pipes. Now, if I just zoom in a little, now what we're seeing is a nice map of all the pressure zones, right? The blue, the one that dominates the map, is essentially at 55 PSI. It's the distribution that's servicing all the businesses, the houses down at that level. And that is actually one entire pressure zone in their data. Now, all the other colors you'll also notice, those are pressure zones. You can see the black one I highlighted is a very large pressure zone at 100 that essentially covers the entire area where that lower 55 psi is coming off of different regulator stations. So I think in their model they're close to 30 regulator stations off of that 100 pressure zone that reduces it down to 55 to be able to now connect what you see all the pipes in blue. Right, so that's how we see that. Now if we go a little bit further, and I haven't finished updating all my data, what you're looking at there is the actual isolation zones. They have close to 150 isolation zones in this one system. Now an isolation zone, of course, is within a given pressure zone, and I'll show this in a second, I can isolate a sub-portion of it, right? And pretty much all of these organizations have these named logically, so they can have work crews dispatched to those. Hey, go shut off that isolation zone. We've got an emergency rupture on the pipe and so forth. So again, as we zoom in more, what we're doing is now actually displaying the data. I'm just using layer rendering capabilities to show the thickness of the pipes based on their pressure level. Anywhere from 900 psi all the way down to that 55, so the line thickness varies. The red dots represents all those regulator stations that help decrease the pressure down. So we'll zoom into an area. This is actually one of their main, I don't even know what it's called in the gas world, essentially a substation that connects to the major transmission that comes in at 900, so it's got all the different regulator stations. But what I want to show you is now some of the tracing capabilities. So I'm going to come over, and the first thing I'm going to do, I'm going to drop a trace location on my map right there, and I am going to do a subnetwork trace. So essentially, remember how we build software. Esri builds frameworks, geoprocessing tools, basic capabilities on our ribbons, right? And what I'm going to show you is our trace geoprocessing tool. Now, would this necessarily be the actual tool your end users would use? Maybe not. You maybe create your own nice little geoprocessing tool that, you know, already has all these values set for them, so it's a single click for a user. But I want to show you the capabilities of the system. So what I'm going to do, I'm working in my Fond du Lac, that was a clue where I am in Wisconsin, database, my utility network, and I'm going to do that subnetwork trace on gas distribution. And I have the three tiers that I mentioned, system, pressure, and isolation. So we're going to focus on the pressure trace right now, and I'm going to run this trace, and given that location, you can see, if I pin this, it just returned the 538 features that make up that specific pressure zone. And if we zoom to that, we can actually see it better. There is my pressure zone representing that specific area. Now, is that exciting? That's pretty cool.
Yeah, it's not bad. This is just the generic software.
Yes, this is
Nothing
generic
custom
software.
was authored here. It's just a framework.
Now, let's go ahead and clear that result set. Now remember what we said, right? These tiers in a pressure environment build on each other, right? Features, that pipe lives not only in the higher level system subnetwork that I showed, right? All those black features initially. It was in that pressure. Now I'm going to show the isolation. So by simply now changing that to my isolation trace, and I run that, now I return 87 features. And there is the actual emergency isolation zone for that pressure zone, because the pressure zone has multiple isolation zones, right? They build on each other. It's hierarchical. Let's go ahead and now zoom back in. And one of the things that we do when we actually maintain this topology, as users edit and you update these subnetworks, that's part of the workflow, right? So if I were to go into an area, and I'm going to add a tap, a service drop, that's going to create my dirty area. Dirty area concepts, the exact same model that we use with topology since 8.3. I do an edit, I see a dirty area, and then I update my topology. And that updating the topology is what maintains all that geeky stuff Erik is in charge of.
And we also used it with our network data set, our transportation network model at 9.1 as well.
Yeah, so we're building on many of the concepts that we already have, right? But we're enriching them even further for this specific industry. Now, as I said, I was doing those traces. Those traces were doing the actual, looking at the topology, the graph. If I had one of those valves based on its state, it traced through that. Now, one of the things that we do when we update and maintain these, right, if we click on that feature and we scroll down, we have the actual attributes for each of those, right? My system was called the Fond du Lac system. My pressure zone was actually P0628. My isolation zone is called IA01, right? We can update these features very rapidly when we maintain the topology, and we also do the aggregation of those lines, right? When I was showing you the map at the different scales, we're not rendering the individual features. We have another feature class that represents the circuits, the zones, and we populate those and maintain those dynamically as you edit and update your topology. And this is when we also tag all those features for what Erik highlighted before, the purpose of labeling, so I can look at what feature and immediately know what zone it participates in. The other thing that will be there for our upcoming beta, work is happening now and next week, is when we maintain our circuits, our pressure zones, we'll have the ability to have aggregates that you configure the system to say, hey, when I update this pressure zone, my topology, I want you not only, as we aggregate that line or that polygon to represent that zone, I want you to tell me how many service points do I have connected to that area. We can immediately derive that during the trace operation to get counts. I can then store those features on those special layers, so I can now have easy ways to look at my subnetworks and understand the characteristics. For gas, and I guess water, there's something called the MAOP, Maximal Allowed Operating Pressure, right? So that they know they don't increase a regulator that's going to exceed the capability of any pipe or any device and cause an explosion, right? It's going to blow out. So we can trace that line, find the maximum one, and store it as part of an attribute that makes up the.
You want to store the minimum one.
Oh, the minimum. I said it
the point of
backwards.
failure.
Oh yeah, the minimum support.
Don't let them run you down.
I'm not an engineer either.
It doesn't show.
Oh, thank you. All right, now, another nice part of these managing subnetworks, we have a way to actually find and visualize these on the map. So the tool that we've built is, let me get rid of the geoprocessing tab.
We have 9 minutes.
9 minutes? We have to do all this in 9 minutes?
Yeah, we're not halfway through the slides or the demos.
We'll go fast. What? I want to show this one. This is pretty cool. I think this is cool stuff. This is eye candy. So, given wherever I am on the map, I can quickly ask the tool, hey, tell me all the subnetworks in this area. So in this example, we quickly discover this list, and then I can choose one of these, and I can say, I want to activate that as the subnetwork that I'm interested in working with. So, did you notice on the map, what happened was, all the features that make up the subnetwork that I selected IA01, right, are now being rendered in the standard symbology color, but any feature which is not part of that subnetwork is washed out based on the transparency. This makes it very nice for that engineer to then be able to walk the line and say, oh, wow, okay, there's a valve, it's closed, that's why I didn't connect into that subnetwork. Oh, there's another one, I can walk down. So you can see the benefit there, especially with feeders and circuits where we have a number of dense features in an area. I can now easily know what circuit zone I'm working with. Pretty cool?
Mm-hmm. Yeah.
This crowd is so hard to entertain.
Hard boiled. It's Friday morning. They're going, when's the bar open?
God, it's been
Not
a long
soon
week.
enough.
They're like one more
It's been
session.
longer for them having to sit through this. Jesus. Okay, let's try and get through the other half of the presentation in the remaining 7
They're
minutes.
willing to go 10 minutes late, I bet, because this is fascinating.
I feel like Statler and Waldorf from the Muppets up here. Okay. Okay, so tracing, you saw tracing, if you look in the GP panel, there's only a single trace tool, okay? Although in the gallery, we break it out and we show different ones. This is a generic tracing framework. All these traces were implemented using the exact same trace tool. And as Tom said, you can configure these things, you can make prettier ones, you can make nicer, more usable ones that do not expose all the complexities to your user community. Network diagrams, we talked about this briefly, but basically integrated into the utility network is the capability of allowing users to work with diagrams, essentially logical diagrams or schematic representations of their data. It'll come pre-configured with various diagramming capabilities, and you can extend those. You or business partners can extend them to create all kinds of tricked out diagrams. You can use either GP or you can use the SDK, whatever you want. Let's see, there's all kinds of layout algorithms that'll come with out of the box, and you can also author your own layout algorithms. You also get to control the persistence of these. Maybe you just want to have some ad hoc diagrams that you throw away, or maybe you want to keep them persisted inside your system, inside your geodatabase. Also, based upon these diagrams, we can tag the diagram when the underlying feature has become dirty and the diagram needs to be regenerated. Okay, if one of the features has been modified that's in the diagram. Okay, let's see, what else?
Oh, good, I get to do a demo.
No.
Oh, please, please, please. This is a cool one. Come on, this is the trace one. 1 minute, give it to me. I didn't even have time to get it configured.
What, you're not configured yet?
No, here it is, I'm on.
Yeah,
okay.
you are.
What am I doing? No.
Burning time, okay. That's what you're doing.
Back on the electric side, I'm zoomed into my couple of circuits. I've placed a starting location, my little green dot. And again, here's the trace tool that Erik was highlighting. So again, I configure it, I tell it what type of trace type I'm going to do. I can do subnetwork traces, upstream, downstream. Let's do a downstream electric distribution on my medium voltage. I'm going to stay on that tier. And what I want to do, this is Erik's example of the configuration of the trace framework. I can specify all these different ways of how to do functions, like we talked about aggregating the number of counts of customers or service points. I can do all this very easily. I can terminate at specific devices. But what I want to do a nearest. And from that starting location upstream, I want to find the nearest based on that category I talked about before, the nearest protective device. And if I run this, let's see if this actually works for me. Oh, it did. It returned one feature. So from that location, I'm going upstream, and I want to now find what that protective device is, and I can now zoom to it. Oh, it's a fuse, and it's part of this fuse assembly, right? So what we've built here is a very powerful framework to do all the tracing analytics, right? Before the geometric network, you had to do a lot of programming. And everything that we're doing here is a call against the REST endpoint. Exact same calls that you would see here. Very easy to call the REST endpoint, the Utility Network Analyst Service. And back to you. Those who want to stay afterwards can see the cool poll report.
That sounds great, Tom. Okay, validating the network topology. It's very similar to the topological validation. What we're basically doing is consuming the network model, all the metadata, looking at all the various different rules and all the features that have changed in the dirty areas, and we're rebuilding the underlying network topology just in those particular areas. If there are features that do violate the rules that you have configured with your particular utility network, error features will be created, much like ArcGIS topology. And then the discovery and inspection of errors and the correction process is, again, very much like ArcGIS topology, okay? These things will be persisted. You can then go back and correct the problems. Let's see, transaction model. We talked about there being a new versioning model implementation. That's very cool, but the user experience will be the exact same as it is today. You're not going to have to learn any new concepts or anything. It's the same user experience underneath the hood. We've developed a second versioning model. There are 3 workflows that we can support, of course: high isolation, essentially long transactions that you do today, and that'll be through feature services. You can do disconnected local editing using sync and feature services, and then you can also do short transaction connected editing to the feature and utility analyst services. So you can do high isolation, disconnected, or short. Benefits: no need to reconcile and compress nightly. It's a different implementation. Performance is much better, more scalable queries, simpler queries, and it does have temporal capabilities. We are putting timestamps in there such that then your data inside default, it actually becomes a temporal database. So you can rewind and see what happened 3 months ago inside your system. Attribute rules. This is a way to essentially, there are various different attribute rules that we're supporting to allow you to control how feature attributes are populated, or whether the feature is considered correct or not. Let's go through some of them. So, simple example, field A is equal to a concatenation of field B plus field C. This is using the arcade language that you heard talked about on the plenary. It's a cross-platform scripting language. It'll run in desktop, mobile, and through the web. The types of attribute rules are calculation rules. Those are things that will populate attributes based upon other attributes on a single feature or related feature. There are constraint rules. A constraint rule is another arcade expression where when you're trying to persist that particular feature, if the constraint rule is violated, we will not allow, an error will be raised when you're trying to save it. Finally, there are validation rules. These are heavier weight things that are going to be checked during a batch validation process. If a feature is found to violate a validation rule, error features will be created much like ArcGIS topology. Okay? Editing. Okay, snapping in Pro is controlled through the connectivity rules. The Pro client actually pulls up the utility network metadata and pre-configures the snapping environment. So you can't snap that water main to that substation transformer, okay, if you do have water and electric inside your utility network. There's all kinds of preset templates and whatnot that you can do to repeat various configurations, be able to lay down these assemblies, such as this overhead switch tap where you see a bunch of arresters and switches and grounds, all kinds of stuff. Also, these things can be stored inside the data source, okay? So these things are persisted as you would expect.
This is a very important slide. Not that one, your next one.
Oh.
This one.
I was going to go editing.
This is it.
Okay, this is a service-based architecture. When Scott and Sud told us we were going to do this project, they then laid it on us a little bit later that this is going to be completely service-based. When you are using the utility network, you will never connect to your Oracle instance in client server. Can't do it, we will not allow it. SQL Server, DB2, or Postgres. Or when we do release it, SAP HANA will also be there as a geodatabase that supports the new versioning model and the utility network. Okay? Now, what we've had to do in order, this is, you can see on the bottom, Enterprise or the portal. You can see the client on top, either ArcGIS Pro or the SDK currently. They both talk to the geodatabase. The geodatabase then talks through JSON to the feature service using the REST API. That sits on top of the geodatabase that behind the scenes will talk to the enterprise geodatabase in client server mode. You can't do it, but the services will. So we've extended feature services. We're introducing some new services. One will be the utility network service. This will be doing things like validating your network topology, or running a trace operation, or doing sub-network management. That will all be available through the REST API. But again, if you're just using Pro or the SDK, this is all completely hidden to you. A user doesn't need to know that they're editing against services versus client server. For them, it's completely opaque.
Because remember, the user connected to their portal with their identities, they saw what maps have been shared with them or what Pro projects, and they open up those directly. They have no idea what's going on in the background.
Okay, we also have a network diagram service. As we were talking earlier about network diagrams and schematics, those have their own service that's made available for organizing, building, and maintaining the network diagrams. Finally, there's a new version management service. This is for all things version management, creating versions, deleting versions, reconciling versions, posting versions, altering versions, looking at differences, seeing conflict sets, all the rest.
And the versioning service with 10.6 release with our new versioning model can work without a utility network, right? As I said earlier, these new capabilities, many of them, like attribute rules as well, work across all of the geodatabase, all of our services capabilities.
Yeah, these are all new platform capabilities. Now, this whole thing, this is the new pattern that we're using inside development at ESRI for introducing new data set types. They're all going to be service-based in this manner moving forward. We will not be supporting client server for new data set types. Well, we may, but at least I'm unaware of it at this point. This is a brand new pattern, and this project is really a groundbreaking one for ESRI development. Okay, network management partners are still part of the process, although we have all this pile of functionality and everything. There's still a whole lot that needs to be done. We showed you some very generic frameworks. When Tom was doing the traces, there was a lot of meat and gore inside that GP tool that you're not going to want to have your users exposed to. Partners will continue to do complex analytics on top of these frameworks, being able to do integration, create better productivity tools, even better enhanced editing experiences and whatnot. How can they extend it? They can create custom tools. They could do new services, including service object interceptors. They can create custom apps. They can write their own apps, your own little things that sit on your phone or your tablet or even your desktop, okay? So partners are still a fundamental part of this solution. Moving to it, they'll be very important about that. We will be providing some basic data models through the services team, and then you'll see other people augmenting those things. We expect people to use geoprocessing models and Python scripts in order to convert and load their data into this new system. And we'll be providing some examples. I'm sure it's going to be a very fertile space for our business partners in this area as well. Continuing the growth of the platform, portals at the heart of it. This is all service-based. We'll be supporting desktop, devices, mobile devices. Runtime will come along next year. You'll get your utility network on runtime devices next year. And then it'll also be made available through the web so you can do your thin client web applications. We'll be extending the JavaScript API to have utility network components, much as we've added utility network abstractions to the Pro SDK. And the same thing will be said in the mobile arena, where your 5 or 6 different mobile SDKs, they will then begin to be lit up with utility network concepts and abstractions. Building a better framework, okay, blah, blah, blah. You start with a platform, you add some more stuff, and then you're done.
That was good. Time
I don't know,
frames.
it's turtles on turtles. Time frames. Okay, last slide. Is Larry going to allow us to show any of this, Larry?
It's all up to you guys.
Okay. Thank you for your kind permission, Larry, and your encouragement. Okay, subject to change. These are the plans as of
Now.
the beginning of this slide deck. When Tom was demoing, I was doing productive work. Beta 1, the first real beta that you guys will be exposed to will be in about a month's time frame. We're hoping for early April. It'll be built as a collection of overlays on top of Pro 1.4 and ArcGIS 10.5. Okay?
Correction. This beta, you'll have an MSI for Pro. You'll get a whole new MSI, which is essentially 1.41 with
Ooh, yes.
just an MSI. But you'll get an MSP for 10.5 server to install. No changes on Portal.
And I'm the geeky one?
Yes.
MSI, MSP? Okay. The second big beta, where we expect to be feature complete, including having attribute rules, is in the June timeframe. That will be based on top of Pro 2.0 and ArcGIS 10.5.1. And are those MSIs?
Yes, we'll do
Okay.
MSIs and MSPs as well.
Okay. Then there will be a pre-release. A pre-release in the September-ish timeframe.
Did you forget to tell them not to take photos?
Oh. Shit. I'm so busted.
You're going to be busy this summer.
Okay, pre-release September. That'll be based upon a Pro 2.1 beta as well as an ArcGIS 10.6 beta release. And then final before the end of the year. We've been told very firmly by Jack Dangerman and Sud Menon that this thing will be shipped this year. Okay? Yeah, so that's enough of that. We're not gonna show that thing anymore. Nope, can't see it anymore. That's
All right, well, thank you for going along with us. We appreciate all those questions during the session. Because we had so much time to take them. Feel free to approach us afterwards. Enjoy the lunch and the closing session. Take care.
Okay, thanks everyone.